We are going to continue talking about our vectors today. But we're going to kind of work backwards from what we talked about yesterday. Like if we have magnitude and we have direction, can we write our vector? Okay. We'll also get to see some applications in terms of adding forces together. Okay. So let's start here. Okay. So here I have magnitude, and here I have our direction angle. Is there a way for us to figure out what the horizontal component and the vertical component are if we know magnitude and direction? I'm going to give you 30 seconds to brainstorm at your table how we might be able to find horizontal and vertical components for our vector AB. Go. All right, pod 3 back there. What do you think? Okay, so if I want to find the horizontal component A, what would we have to use? Okay, we know that the cosine of theta is adjacent over hypotenuse, right? Okay, so if we wanted the horizontal component A, we can multiply the magnitude over. Do you agree? Okay. What about B? How could we find B? Sine is opposite over hypotenuse. Okay. Well, if we want vertical component, then once again we can multiply that magnitude over. Okay. So if we want our separate components, our horizontal component is going to be could be written as the magnitude times the cosine of our direction angle. And the vertical component could be written as the magnitude times the sine of the direction angle. In linear combination form, we have the same thing. Just remember that we essentially have our vertical component as a coefficient for I, plus our horizontal component as our coefficient for I, plus our vertical component as our coefficient for J.
Yes, in Shrek, the first movie. When they're fighting off the knights for Lord Varda. That's what Fiona. Donkey kicks a man in the face, and it snaps his neck. Oh, he just killed a man. Yeah, Donkey's killed a person.
Okay.
But not only that, but when he kicks it, he has full plate armor on, and it doesn't bend. Which means that the steel that Lord Farquaad used is like godly. So.
Okay, I'm glad that you're
for
staying focused on math. Okay, go ahead and write this down. I want us to find the component form of vector V if we know that the magnitude is 2 and the angle is 45 degrees. Our direction angle is 45 degrees. Okay. Okay. We just talked about how our horizontal component is the same thing as magnitude times the cosine of the angle. And our vertical component is the same thing as magnitude times the sine of an angle. Now, is 45 degrees a special angle? Do you think I want you to use your calculator on this one? No, I don't. Okay, I want this to be exact. If you ever have a unit circle angle, I do want exact values. Okay? I still expect you to remember those numbers. So this is easy though. What's the cosine of 45 degrees? Radical 2 over 2. Multiplied by this 2, we have radical 2. The sine of 45 degrees is, oh, wow, only Max?
Yeah.
The sine of 45 degrees is
Radical 2 over 2.
It's going to be a long quarter. It's Tuesday. Okay. Go ahead and write this one down. We're doing the same thing, but I'm giving you slightly different information. Okay. So I give you the magnitude, but then I give you a different vector. Okay. I'm saying that our vector v is in the direction of this guy right here. So what do we need to find? What? Yeah, the angle. So I'm going to give you a moment to, at your table, come up with what you think the angle of this vector is. You're finding to be the angle of negative 3i plus 4j. You need to reference your pink notes sheet, you may.
Yeah.
Oh, right. I actually didn't call.
What do you have to do?
Did you remember what?
No, you just added to. Oh,
Well, you need the angle in order to do that, which is what we need to find. Okay, so what do we do?
That's what we're trying to find. An angle that's at the same.
So one
I think it's at the same angle as this, but only has a magnitude.
plus 270. Right? Because it's like one quadrant.
Yeah, so
Add
270
270 plus this.
Well, good.
yeah.
All right, in order to find the direction angle, what's our first step? You say draw a triangle? Here's our vector, right? We went over 3 up 4. We need to figure out what that angle is right there. So what are we going to write? Okay, the tangent of theta is 4 over 3. So in your calculator, you would need to type in the inverse tangent of 4/3. Whether you type in negative 4/3 or positive 4/3, it's really not going to matter. Some of you have this 3 as negative, some of you have it as positive. I don't really care. What does your calculator spit out when you do that? 0.13. Okay, but is that our direction? No, we have a second quadrant vector, which means our direction is actually 180 minus 53.13, which is you could help me.
126.
There we go. Okay. So now we have our direction angle. Okay? So if we want the component form of V, now we can take our magnitude times the cosine of the angle for our horizontal component and our magnitude times the sine of our angle for our vertical component. Those of you who are punching into your calculator, what do we get for our horizontal component? Negative 1.8. And what about our vertical component?
2.40.
Good. Okay. So we had to find the direction angle of this guy because we knew vector v was in that same direction, and then we could use the magnitude times cosine of theta and magnitude times sine of theta. All right. Now, I want us to add two vectors together. We can do that, right? We can add two vectors together. And in your homework last night when we had numbers, did that go okay?
Yep.
Yeah, pretty nice, right? This time, however, I'm giving you the magnitude and direction of the two angles I want you to add together. We cannot add our two vectors together unless we know each of the components. When we did vector addition, we added the horizontal components together, we added the vertical components together. Okay? We cannot add these two vectors together the way that they are. We need the components of each in order to be able to add them together. So, we need to actually write vector u and we need to write vector v. Okay? So let's start with vector u. So vector u, in order to write each of the components, we need to write magnitude times the cosine of the angle and magnitude times the sine of the angle. $60 degrees is one of our special angles, so I will expect you to give me exact values here. What is the cosine of 60? 1/2. So 1/2 times 4 would be 2, which means the sine of 60 is radical 3 over 2 times 4 would be 2 radical 3. Okay. Now let's focus on vector v. Vector v has magnitude 5 and a direction angle of 90 degrees. So for our horizontal component, we would write 5 cosine of 90 degrees. And for our vertical component, we would write 5 sine of 90 degrees. Cosine of 90, 0. And the sine of 90, okay. So vector v is the vector 0, 5. Okay. Well, if I want the vector u plus v, now we can add our components together. 2 plus 0 is 2. Okay. And then 2 radical 3 plus 5. 5 doesn't have a radical 3 attached to it, so we really can't combine them. So I'd ask that you just write it as 5 plus 2 radical 3. And there's our vector. Okay. We're going to do 2 application problems. Okay? Vectors can be very, very useful. And if you've had physics or you are in physics, you've maybe already seen the application of vectors. Have you done your vectors unit?
Yeah, a long time ago.
A long time.
Like
first
beginning of
quarter.
first semester.
Oh, okay.
So, yeah.
What did you say?
Yeah.
Okay. Well, we won't get quite into everything that you did in physics. Okay? But what we can understand about forces, okay, if we have forces, we can represent them with vectors, okay? And the magnitude of the vector is the amount of force being applied in that direction, okay? So when I talk about like a force of 2,000 newtons, I have it written for you here, magnitude. Okay, but like a force of 2,000 newtons means that vector has magnitude 2,000. Okay, and 900. Act on a machine part at angles 30 degrees and negative 45 degrees respectively with the x-axis. Find the direction and magnitude of the resultant of these forces. Okay, so first I'll go ahead and let you write down whatever you need to in order to come back and look at this in your notes. And then we're going to talk about what they're actually asking you to find. Okay, resultant. We talked about that word yesterday. What's that referring to? It's the vector that comes from adding the two together. Okay? So we have 2 forces acting simultaneously on a machine part. Okay? One's coming from a 30-degree angle, one's coming from a negative 45-degree angle. Okay? These 2 forces acting on the machine part is actually creating, like we can combine those 2 forces together to figure out what is actually happening on that part. Okay? Now, we have magnitude and we have direction. And what I'm asking for is the magnitude and direction of the resultant. So first we're going to have to figure out what our vectors are. We're going to have to add them together, and then we can find magnitude and direction from there. Okay? So let's just call, I'm going to underline this in blue, and we'll call that, thank you. Okay. We'll call that vector u. Are you okay with vector u? Okay. So vector u has a magnitude of 2,000 and an angle of 30 degrees. Since that's the case, then vector u is 2,000 times the cosine of 30 times 2,000 times the sine of 30. Okay, 30 degrees is that nice angle, right? Yeah. The cosine of 30 degrees is radical 3 over 2. Times 2,000 would be 1,000 radical 3. Okay. The sine of 30 degrees is 1/2. Times 2,000 we would have 1,000. Okay. Next, we have a force of 900 newtons at a negative 45 degree angle. So let's call that vector V. So vector V has magnitude of 900 with an angle of negative 45 degrees. So if we want the components of vector V, we need to take 900 times the cosine of negative 45 degrees and 900 times the sine of negative 45 degrees. Okay. Well, we know that the cosine and sine of any 45 degree angle is radical 2 over 2, but we are in the fourth quadrant. So the cosine of negative 45 degrees would be a positive radical 2 over 2. And the sine of a negative 45 degrees, sine is negative in the fourth quadrant, so we have negative radical 2 over 2 times 900. Okay, so here are the components of our two vectors. Now, these vectors are acting simultaneously on this machine part, essentially creating one force, so that's what we're going to determine. Okay? So the vector that is created by these two forces acting together is u plus v. 1,000 radical 3 plus 450 radical 2 would be our horizontal component. We can't really add those together, right? And then 1,000 plus negative 450 radical 2 would be our vertical component. Well, they were concerned about the magnitude and direction of these forces acting together. So we have found the vector, but we need the magnitude and direction. Okay? So, this I'm going to call A, and this I'm going to call B. We need to figure out the magnitude by taking the square root of a squared plus b squared. And we need to find the angle by taking the inverse tangent of b over a. Okay, so how about, most of you have 4 people at your table. 2 of you work on the magnitude while the other 2 work on the angle. Okay, so you at least have somebody to compare answers with. Okay, so divide and conquer here for me. Your calculator has nice parentheses and order of operations that can help you. Make sure you use your parentheses. Or if you want to figure out what A is in decimal form and B is in decimal form, and then use your arrows to call them back up, or your store button to call them back up, that's also fine. The angle is very small, and the force is a little bit bigger than 2,000. What was the second decimal after this? This should be your angle, 8.73 degrees. Is that what you are getting? Anyone else having trouble with their calculator to get 8.73? Your magnitude. Drum roll. What's the next decimal? I didn't write it down.
Yeah, definitely.
It was 1946.
19. And what would the label on that force be? Newtons. Okay, any issues with your calculator there?
Big time.
Cool.
I didn't even get close to that. I put like double parentheses though, so like you can see the whole thing. Yeah, I just put parentheses right here.
Oh,
Why didn't you do that for me?
Oh my gosh. Jeez, that's
okay. All right. Other issues? Other calculator issues I need help with? Okay. Knowing how to work your calculator is a beautiful thing. Okay. Last example. A slingshot. How many of you had slingshots growing up? Or still do? Only one? Okay, a slingshot is fired at a velocity of 30 feet per second. If I were you, I would write velocity 30 feet per second. At an angle, and then I would write angle of 20 degrees. Find the vertical and horizontal components of the velocity. We can represent velocity as a vector. Okay? Basically, we have this, we're going to call it a rock out of a slingshot. Gets fired at 30 feet per second at an angle of 20 degrees. Okay? 30 feet per second is representing the what of the vector? The magnitude. So if I want the horizontal and vertical components of our velocity, all we're doing is breaking this up into a vector in component form. Okay? All we would need to do for our horizontal component is take 30 feet per second times the cosine of 20 degrees. Somebody could punch that in their calculator, please. 28.19. What?
28.19.
I could have sworn you said, oh, wait, hold on.
Oh, I didn't.
I know. Isn't that? I believe you. But, like, however those syllables came out. Okay? And then our vertical component would be that 30 times the sine of 20 degrees.
10.26.
And we're still going to label these components as feet per second because that's what our magnitude is labeled as. Okay? So this is what I want you to imagine. Okay, what does it matter what the horizontal and vertical components are? Okay? Let's say I fire this slingshot and Dallas is laying on the ground. You're laying on the ground. If he's laying on the ground horizontally, then he's going to see that rock travel at this 28.19 feet per second because he's only seeing the horizontal piece. You see what I mean? If I'm shooting it at somebody, they're standing vertical, they're only going to see it rise at that 10.26 feet per second because they only see that vertical change. Okay, until hopefully it misses them. Okay, so do you kind of see how what we did yesterday, this is sort of like working backwards from, like we have the magnitude and direction, let's take that and break it into our two components. Okay, so you have a homework assignment tonight. Tomorrow we have block scheduling, which means I have you for like an hour and 40 minutes. This is what I'm going to do. We are going to have a normal lesson. You'll have time to do homework, and then we'll do an activity to practice all of these different items that are associated with vectors. So you'll get up out of your seat, and you'll get to talk to people and move around, and you won't be sitting here bored out of your door.
Maybe this is why I don't like